There's a special case. So if we know x and y have the same population standard deviation, then we use a different formula instead. This doesn't really happen often because we usually don't know the values of standard deviation. So the new formula is given by the first part is the same, x bar minus y bar, plus minus the t part is easier, so the degree of freedom is nx plus ny minus 2, comma alpha over 2. But this part is a little different, so here we have a term sp times the square root of 1 over nx plus 1 over ny. So I have to tell you what SP means. So SP is the pooled standard deviation. It is defined by the formula that's rather complicated. So now we have a different formula for confidence intervals if we know the population standard deviations are the same. So let's do an example. So let's use the same scale to weigh 2 different bottles. So because we're using the same scale, and if the 2 bottles have the same ideal weight, we can assume the measurements of the 2 bottles have the same population standard deviation. Okay, so let's do some measurements. So the first bottle, we took 18 measurements, and the sample mean is 2.007, extra 0 here, 2.007 kilograms, and the sample standard deviation is 0.01 kilograms. So that's bottle number 1. And for bottle number 2, we took 10 measurements, and sample mean is 2.001 kilograms, and the sample standard deviation is 0.012 kilograms. So remember, these are sample sizes. Okay, so we can first calculate the pool standard deviation SP, which is the given by this rather complicated formula. We have all the numbers we need, just plugging into calculator. This is equal to 0.0107 kilograms. So now we can construct a 95% confidence interval. For the difference of population means, which is the true weight of the 2 bottles. So it's given by x bar minus y bar plus minus t. The degree of freedom is 18 plus 10 minus 2, comma alpha over 2, which is 0.025. 0.025 times SP times the square root of 1 over nx plus 1 over ny. All these values can be found above, and the t value can be found using the t table. This is equal to 2.779. So after plugging everything in and use the calculator, the confidence interval is equal to 0.06 plus minus 0.012 kilograms. So that means we are 95% confident that the 2 bottles differ by this much weight. Alright, so that's it for section 5.6.